Welcome to the next lecture that is on elementary combinatorics. This lecture topic is now permutations. So actually now we further studied about the permutations and combinations. So what is the permutation? Actually permutation is measure that the here order ma- uh, the ways to calculate the order is matter here, and in combination order is doesn't matter. So first we talk about the permutation. So what is the difference between permutations and combinations? Both are the ways to count the possibilities, right? But the difference is that in which there is order is matter or not, right? In permutations order is matter, and in combination order doesn't matter, right? So now next is that suppose we have a poker hand like that. That is the symbol of the poker hand. 5, 7, 10, k, these are the cards we have. So and can we say that is the same hand as like that if we write that k 7 k 10 7 5 a? Yes. Does the matter the card had handed matter out, right? So if this order matter means, so we have to deal with the permutation. If this is not matter, the order is not matter, so we have to deal with the combinations. So here first we talk about the permutation. So what is the permutations? A permutation is a set S of objects is an ordered arrangement. We have to concentrate here, ordered arrangement of the elements of S where each element appears only once. So in permutations, we have to take the arrangement, right? So like we have these numbers 1 2 3 2 1 3 3 1 2. So here if order is matter, so we use the permutations. And if we have the total n objects, so for n objects and we have to arrange out of n, we have to arrange the n objects, so that is permutation is n factorial, and this comes from the product rule, right? So an ordered arrangement of r distinct elements of S is called an R permutations. R means we have, suppose total elements are n, in which we have to arrange r distinct elements. So this is the R permutation. So the number of R permutation of a set S with n elements, that is represented by P and R. We can represent it. P and R means that we have total n objects, n numbers are there, and we have to arrange out of these n, we have to arrange R objects. So we calculate P and R, and this value is n, n minus 1, n minus R plus 1. This is the multiplication, n multiply n minus 1 multiply n minus 2 up to n minus R plus 1. So we can arrange it like that, n factorial upon n minus R factorial. So the value of P and R we calculate by n factorial upon n minus R factorial. Now, permutation formula proof. Mean how can we get this formula? If we have suppose n ways to choose the first element, and n minus ways to choose the second element, and n minus 2 ways to choose the third. So like that, up to n minus r plus 1 ways we have to choose the rth element, right? Because third element we have to n minus 2 ways. So rth element we have the n minus r plus 1 ways, right? So by the product rule, we use here product rule, n multiply n minus 1 multiply n minus 2 up to n minus r plus 1. So we will get the P and R. Now let's take an example here. In a running race of 12 sprinters, each of the top 5 finishers receives a different medal. So, how many ways are there to award the 5 medals? How many ways to award the 5 medals? So, here we have given the some options are there. So, what will be the answer of this? Can you tell me what will be the answer? Yes, that answer is 12 factorial upon 7 factorial. How is it? Here we have the how many medals? 5 medals are there. So 12 persons will get the 5 medals. So first medal get the, how many options for the first medal? 12 sprinters can get the 5 medals. Now here we have to say that a different medal, each one will get the different medal. So now for the next medal, for to get the next medal, how many persons now we have? The 11 remaining are 11. Next one is for 12, 10, next one is 9, next one is 8. So this is 12 multiply 11 multiply 10 multiply 9 multiply 8. So what it will be give? This is the product rule, right? So and in terms of factorial, how can we write this? Because if we use here the permutation, so total we have the 12, means this is our n and this is our r is equal to 5 and n is equal to 12. So how many ways here to award the 5 medals? N factorial means 12 factorial upon n minus r factorial. N minus r 5, 12 minus 5 is 7 factorial. So we can write this 12 factorial upon 7 factorial, right? Let's take another example. Suppose you have to time to listen to 10 songs on your daily jog around campus, right? There are 6 A tunes, 8 B tunes and 3 C tunes to choose from. Finally, suppose you still want 4A, 4B, and 2C tunes, and the order of the groups doesn't matter. Here, what do you say that? Here we have given that order doesn't matter, but you get dizzy and fall down if all the songs by one group aren't played together. So, how many playlists are there? So, how many playlists are there? Actually, here by combination we can solve it, because here groups order doesn't matter, right? So but with how with the permutations, how can we solve this question? Because if you have any questions, so you can solve it by according to the question you have to that what is given and what he asked. So according to that you have to solve your question. Maybe you can solve it by permutations, and you also can you solve this by the combination. So by the permutations, how can we solve this? This is the we have 6 A tunes was there, and out of 6 we have to take the 4A. So 6 4, so n is 6 and r is 4, so that is p6 4 multiply 8. Out of 8 we have to take 4, so p8 4 multiply out of 3 we have to take 2, so pc3 p3 2, sorry, and 3 factorial. Why we take here 3 factorial? Because here says that order doesn't matter, so it may be anyone in any place, right? So that is 1 1 1, so we have the 3 factorial is also there, right? So if you use here the combination, so you need not need to this 3 factorial, because this already this is value for the combination, right? But according to permutation this will be. Now, next example, how many permutations of A, B, C, D, E, F, G and with A? Means how many permutations we have to arrange this, and the and ending point that will be A here. It is the condition is given. So total elements here we have the 7. 1, 2, 3, 4, 5, 6, 7. Total elements we have the 7 elements. But here says that last character with A, right? So A is fixed, our last character is fixed. So now our variation is only the six remaining 6 elements, right? B, C, D, E, F, G. So 6 permutations on the set B, C, D, E, F, G, right? So what is that? So our permutation is means out of 6 we have to take the 6. So our permutation is P66, that is 6 factorial, because if we have to choose the total number of elements in the total elements, we have to choose all that one time, so that is our n factorial. So here out of this 6 we have to choose all, so that is 6 factorial, right? So 720. Why we take note the 7 p76? Because our and element and character is fixed A, so we have to not touch that. Only our variation is from these 6, so we take our permutation from these 6. Clear? Okay, so now next example is that in how many ways can 5 English, 4 Tamil, and two Hindi books can be arranged if the books of each different language are kept together. So, here we have the, suppose first we consider, because these all are in our unit. So suppose we take that five English book has one unit, and four Tamil book as one unit, and second two Hindi books as one unit. So we take how many units we have? One, two, three. So our first task is that we have to arrange these units one, two, three in a uh, we have to kept together, right? So number of ways arrange three units is that 3 factorial, because out of 3 we have to arrange all these 3, so 3p3, that is 3 factorial. Now we arrange the each language book among themselves, right? First we have to arrange these considering one unit. So now all these five English books we have to arrange all these books also, right? Four Tamil books we have to arrange all these also. So what is the permutations to arrange five English books? That is 5p5, so that is 5 factorial. To arrange the four Tamil books separately, so that is 4p4, 4 factorial. To arrange the two Hindi books separately, that is 2p2, 2 factorial. So now total arrangements, how many ways that we can arrange all these books, right? And different languages are can together, English books together, Tamil books together, and Hindi books together. So total arrangements are 3 factorial multiply 5 factorial multiply 4 factorial multiply 2 factorial. So this is are the required arrangements. Clear? Now let's take another example. How many four digit numbers are there with distinct digits? Four digit number, right? So we have to arrange here four digit number. So we have to arrange here so we have to arrange, actually this will be this yes. So we have to arrange here four distinct digits, right? So here you can see that there are 10 digits. We have 0, 1, 2, 9, right? So we have to arrange here, you can take this, we have to make the four digits 1, 2, 3, and 4. We have to make the four digit number. So four digit number is there, so 0, 1, 2, 3 up to 9. Now so now if we have to make the four digit number, so our 1000's place so cannot be so here our, if we here in this place we can't put 0, right? Because if we put here the 0, then it not make the four digit number, it will make the three digit number. So but we need the four digit number. So our fourth place, or this place, 1000's place, this is unit place, 10th place, 100th place, thousandth place. So this thousandth place is not the our the is notes place is our not the, we can't put here the 0, right? So now number of ways to fill 1000's place, that is we have the 9 ways, right? So number of ways to fill the thousand's place, that is 9, because out of 10 we have the 9 options are there, remaining the 0. So 9 options are there, so we can fill it by the 9, right? Now the remaining 3 places can be filled with any 3 of the remaining 9 digits. So now we have these 3 places, 1, 2, 3. So this will be this place is filled with the 9 numbers remaining for the 0. So now our 3 places, how many options to fill these digits? Because one element is already we put here out of these nines, so remaining elements are 9 elements are here. So we can fill our these 3 places with the remaining 9 digits. right? So number of ways to filling this is all 9p3, right? So now 4 digits number with distinct digits is 9 multiply 9p3. So our required number of arrangements, number of 4 digit numbers is 4536. Clear? Now find the value of r. If you have suppose this type of questions, here you have to find the value of r, and this is given that 5pr is equal to 2 multiply 6pr minus 1. So you have to expand by the formula. What is the formula for NPR? That is n factorial upon n minus r factorial. So this is 5 factorial upon 5 minus r factorial. 2 multiply here, this will expand 6 factorial upon 6 minus r minus 1 factorial. So now you can solve this, and after solving you will get the value of r, because this will be 5 minus r. So 5 minus r factorial is cancelled out by 5 minus r factorial. So and 5 factorial is cancelled by 5 factorial here, and this is will be cancelled out by this. So we have remaining 2 multiply 6, 7 minus r, 6 minus r. So when you cross multiplication this, so after solving this you will get r equal to 3. Similarly, you have to find here the value of n, and the given is that 16 n p3 is equal to 13 n plus 1 p3. So now again you have to use here the formula npr n factorial upon n minus r factorial, and after solving this you will get the value of n equal to 15. Clear? Now permutation of things not all different. If our things are different, so how can we calculate the permutation? So the number of permutations of n things taken are at a time in which k1 elements are of one kind, k2 elements are of second kind, and k3 elements are of third kind. Like that all rest are different is given by. So if we have suppose total n elements are there, and we have to choose out of n r, but in that r elements we have some of one kind, some one are of other kind. So how can we calculate it? This is calculated by r factorial upon k1 factorial, k2 factorial up to kn factorial, right? So these are the different things of to the sum. Now take an example this. How many different arrangements can be made by using 4 red and 3 black identical balls? So now total balls we have, number of red balls are 4, number of black balls are 3, right? So we have to calculate different arrangements can be made. So total balls are 7, right? So we have the 4 balls are red and means one kind of this, and 3 balls are black, that is another kind. So the permutation will be 7 factorial upon 4 factorial multiply 3 factorial. That is total 35 arrangements are there. Clear? So actually you have to see that in permutation you have to be calculate the arrangement, and in combination you have to calculate the selection. So now see here in this example, in how many ways of the distinct permutations of the letters in the word mathematics do the vowels occur together? Vowels, what are the vowels in the alphabet? We have the 5 vowels are there. What are these? A, E, I, O, U. So we have to see that how many vowels are here. So we have to get together of these vowels and to find the arrangements. So first you can see that how many total letters are here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So in mathematics word we have total the 11 letters are there. And out of these 11 letters, how many vowels are there? Vowels A, I, E. So total we have the 4 letters are there, A, E, A, I, which are the vowels are. And so out of 11, 4 are vowels and remaining 7 are our the constants. So when we make a group of these four vowels as one unit, we say that. So how many total numbers are there if we take these four vowels as one unit? That is 7 plus 1, that is total we have the 8 units which we have to arrange, right? So how can we arrange this? By 8 factorial ways. Now in this 8 units, we see that our two m's are there and two t's are there, right? Two m's and two t's. So what are the arrangement of these 8 units? That is 8 factorial upon 2 factorial multiply 2 factorial, because two m's are there, two t's are there. Now our these vowels, four vowels was there, in which vowels we have a is comes two times, right? So what are the arrangement of these four vowels? These are the 4 factorial upon 2 factorial, that is 12. So now how many of the distinct permutations, combined permutation of this is this 10080 multiply by 12. So this is are the required permutation of the word mathematics, which have two vowels together. Now come to the circular permutation. What is the circular permutation? Actually, if we have to arrange like in a circle, or suppose we talk about the that some persons are sitting around the table, or we have to put the if we talk about the arrangement of the pearls which is in necklace, so that is a type of circular arrangement. So this type of circular arrangement is we calculate it is by the permutation. So this is called the circular permutation. So now how can we calculate this? See here, to determine the number of circular permutations we shall consider one object fixed. Means in a circular permutation, if we have to find the arrangements to sitting the around the circular table, so we have to fix one point, then calculate the number of arrangement based on the remaining number of objects left. Then we have to one have at one point we have to fix that, and other we have to see that how can we arrange like this or like this, right? Now the number of circular permutations of n different objects is determined. How can we calculate this? This is the permutation n minus 1 factorial, right? So how many objects we have? That base is n minus 1 factorial. Now let's take an example for this. How many distinguishable ways can three people be seated around a circular table? So three pupils be seated in a circular table. So by the formula we can easily calculate that what are the permutation that circular table. If we have the n pupils, so the arrangement is n minus 1 factorial. So here we have the 3 persons, so it will be 3 minus 1 factorial, that is 2 factorial. So 2 factorial is 2 cross 1, that is 2. So it means two ways we can see that two ways the three persons be seated in a circular table. How can we this? So you can see here, if this is our circular table, right? So here suppose we fix this person 3. So now how many arrangements to sit three persons? So like we put here person 1 here, person 2 here, so like that we can if we fix here person 3, so p1 p2 p3, like that we can sit. Another way how can we sit? Person 3 is here, so if we see here person 1 person 2, so only two ways are there, or you can sit like that or you can sit like that. So total two ways are there to sit three pupils in a circular table. Clear? If suppose we have to sit the four pupil in a circular table, so what will we have to do? 4 people, it means that 4 minus 1 factorial ways these have 3 factorial, and 3 factorial is 3 multiply 2 multiply 1, so that is 6. So total ways is 6, means 6 type of ways we can the 4 people can sit around the circular table. How can you this? So see here, if this is our the circular table and suppose we fix our a person, right? So how can arrangements? First arrangement is like that, put sit 5 persons is like that, a b c d, right? Another way is that A is fixed here, A, B, D, C, right? Now another way is that A, B, C, D. We can arrange here. So B is now again A, B, C, D. We can sit like that in a circular table. Another arrangement, we put A, B, C, D. Another way we can put here A, B, D, C. So any no other way to sit in a circular table except all these, right? So total number of ways, we have the 6 ways to sit 4 pupils in a circular table. Clear? So now next example is that there are 5 men and 4 women to sit around a round table. In how many ways can they sit so that no 2 women sit together? So what we do here, here we arrange 5 men around a table, right? So we arrange here our this round table and 5 men, 1 2 3 4 5 5 men are arranged here. So how many ways to sit 5 men in a circular table? That is n minus 1. So 5 minus 1, 4 factorial ways to sit the 5 men in a circular table. Now 4 women are also there, sit here, but we see that no 2 women sit together. So how can we it possible that no 2 women sit together? Means if a woman sit here between the men, then we can say that 2 women can't sit together. So how many options to sit the for the women? There are 5 places in between the men. You can take 5 places, 1 2 3 4 5. So here we have the 5 places to sit the women. But how many women we have? 4 women are there. So we have the 5 places. So 4 women sit in the 5 places so that they can't sit together, right? So number of ways to arrange the women is 5p4. So the number of ways which no 2 women sit together, that is 4 factorial and multiply by 5p4. So our the total arrangements are 4 factorial, that is 24, 5p4 is 5432, that is 2880. So the required number of arrangement, that is this one, to sit that no 2 women sit together in a circular table. Clear? So now, thank you. Today's lecture is completed now. People